Welcome back. In this section, we're gonna dive even deeper into React hooks. So I like to say that hooks are easy to learn in the beginning, but hard to really master. However, a really solid understanding of hooks is crucial for all React developers. That's why, over the next few videos, we'll understand the rules of hooks and why they exist, learn even more about the useState hook, explore the useRef hook, and even create our own React hooks. Now, we won't revisit the useEffect hook yet, because we will inspect it even further at a later point. But anyway, let's get back to work and finish building this project. We have already used a few different React hooks at this point of the course, but we have never really learned what a React hook actually is and how they work. And so let's now do that in this lecture. So, React hooks are essentially special functions that are built into React and which allow us to basically hook into some of React's internal mechanisms. Or in other words, hooks are basically APIs that expose some internal React functionality, such as creating and accessing state from the fiber tree or registering side effects in the fiber tree as well. So again, the fiber tree is somewhere deep inside React and usually not accessible to us at all. But using the useState or the useEffect hook, we can essentially hook into that internal mechanism. Now, hooks also allow us to manually select and store DOM nodes, access context, and many other things. Now, what all hooks have in common is that they all start with the word use in order to make it easy for us and for React to distinguish hooks from other regular functions. And in fact, we can even create our own so-called custom hooks, which will also start with the word use. And this is actually one of the greatest things about hooks in general, because custom hooks give us developers an easy way of reusing non-visual logic, so logic that is not about the UI. Now, you might be aware of this or not, but there was a time when we had to use components based on JavaScript classes if we wanted to give components state and access to the component lifecycle. However, this came with a few problems, which led the React team to introduce hooks. And so now, with hooks, our components based on functions can have their own state and also run side effects. And so this was a huge step forward for React and made it even more popular than it already was. Now, we only used 2 hooks so far, but React actually comes with almost 20 built-in hooks, and so let's get a quick overview of them here. So useState and useEffect are of course some of the most important hooks and therefore the most used ones, along with useReducer and useContext that we will actually study pretty soon. Then we have this huge list of some less used hooks, but where some of them are actually still quite important, like useRef, useCallback, and useMemo. So some of these are actually worth learning, but others are a bit more obscure, I would say, and so they are not part of the curriculum of this course. And finally, there are a few hooks that are intended only for library authors, and so of course we will also not bother looking at those. Now, in order for hooks to actually work as intended, there are 2 very simple rules of hooks that we must follow. The first rule is that hooks can only be called at the top level. In practice, this means that we cannot call hooks inside conditionals like if statements, and also not inside loops or functions nested inside the component. We can also not call hooks after an early return, because that's also similar to a condition. But why? Why is this such an important rule? Well, it's because hooks only work if they are always called in the exact same order, which can only be ensured if we only call them at the top level. And we will look at this in more detail in the next slide. And now the second rule is actually a bit simpler. All it says is that hooks can only be called from React functions. In practice, this means that hooks can only be called from function components or from custom hooks, but not from regular functions or even class components. Now, the great news is that you actually won't have to worry about these rules at all if you're using a linter, because these two rules are automatically enforced by React's ESLint rules. So you really won't be allowed to break these rules, even if you try, like we will in the next video. So if you want, you can actually just forget about the rules and finish the video right here. But if you're curious about the deeper reason why React needs rule number 1, then let's move on to the final slide of this lecture. So let's now try to answer the question of why do hooks need to be called in the same order on every render? And let's actually start from the very beginning, based on all the knowledge that we already have at this point. So remember that whenever an application is rendered, React creates a tree of React elements, also called the virtual DOM. On the initial render, React also builds a fiber tree out of the virtual DOM where each element is a fiber. Now, each of these fibers contains a lot of stuff, like the received props, a list of work, and, crucially for us, a linked list of all the hooks that were used in the component instance. So, to understand how hooks work behind the scenes, let's build ourselves a linked list of used hooks based on this hypothetical code example. And I say hypothetical because this code actually doesn't work. And can you spot why that is? That's right. This code actually violates the first rule of hooks because it conditionally defines state here. But by breaking this rule, we will understand why hooks rely on the order in which they were called. And speaking of this order, our list will be built based on the call order of the used hooks. So first, this useState call, then another useState call, and then finally this useEffect call. So this is our list of hooks, but it's not a linked list yet. But what does linked actually mean? Well, it means that the first list element contains a reference to the second element, which in turn has a link to the third list element. So all the list elements are linked together, which is actually a common data structure in computer science. But anyway, moving back to our code example, let's now imagine that a re-render happened because state A was updated from 23 to 7. But this now creates a huge problem. Notice how state B was only created initially because the condition A equal 23 was true, right? However, after this re-render, the condition is now false, which means that this useState hook would not be called. And so state B would then no longer exist in this linked list of hooks after the render. But what's the problem with that, you might ask? Well, the problem is that the first hook is still pointing to the original second hook, so to state B, but that link is now broken. So state A is now linking to a hook that no longer exists, and nothing is pointing to the effect hook Z, meaning that the linked list has been destroyed. It works this way because fibers are not recreated on every render, and so this list is also not recreated. So if one of the hooks just disappears from the list, then the order of the list will get completely broken. So in conclusion, if we conditionally use a hook like we did here, that will completely mess up the list of hooks between renders, which will leave React confused and unable to correctly track all the hooks that were used. And so this is the reason why hooks need to be called in the same order on every single render. And the only way in which we can assure that is by only calling hooks at the top level, which is exactly what the first rule of hooks says. So following this rule, the code and the list of hooks would look just like this. So without any conditionals in the code and with the list of hooks always in the same order. Now, of course, this opens up the question of why even bother having this linked list if it requires this strange rule to exist? Well, the big reason is that a linked list, which relies on the hook call order, is the simplest way to associate each hook with its value. So basically, the order in which the hook is called uniquely identifies the hook. For example, React knows that hook number 1 has a state of 23, and that hook number 2 has a state of empty string. So the value is associated with the call order. And this is very convenient because by using the call order, we developers don't have to manually assign names to each hook, which would create multiple problems that we don't need to get into at this point. All right, so I hope that you didn't mind yet another deep dive into some of React's internals. I personally find these really interesting and fascinating, which is why I keep getting excited to share this stuff with you. But now it's time to get back into writing some code. Let's now actually break the main rule of hooks that we just learned about, which is that hooks can only be called at the top level. And here I still have the Use Popcorn app open, both in VS Code and in the browser. And so that's because we will keep working on this app in this section. And so if for some reason you closed the application, then make sure to just open it up again here. Now, just like before, I will again duplicate this file here, and then I'm going to copy, or actually I'm going to call it v2. And so again, with this, we then can keep our previous versions of the code. And let's actually get rid now of this dummy data, just like this, and also of this comment. So cleaning up the code a little bit. But now let's break some rules here, which, as I mentioned before, is always a great way of learning why the rules exist in the first place. So coming here to our movie details component, this is where we will now write some code to break that rule. But let's actually start by again searching for some movies here. And then I will open this one up so that we can check out the hooks that we actually have right now in this component. So in the DevTools, check out the movie details component, which is this one. And so down here, we have the list of hooks that we just saw in the previous lecture. Let's make this even bigger. And so indeed, you see that the hooks are actually numbered. So in fact, each of the hooks is identified by React by their order number. Not some name or anything like that, but really only the number. So this first hook here is exactly this movie. Then we have the isLoading state, which is currently false. Then we have the user rating, which is this one. And then we have our 3 effects. All right, so the 3 effects down here. Okay, now if we did call a hook outside of the top level, so basically if we called a hook conditionally, that would mess up this entire order here. And so that's where we would then run into problems. And that's exactly what we want to do now. So let's experiment here. And let's say if the IMDb rating is greater than 8, then we want to create 2 new variables called isTop and set is top, and then equals use state set to true. Now, as we save this, VS Code will immediately complain and tell us that here we are not allowed to use state conditionally. Okay, but we can actually disable this ESLint rule. So just write this comment here, ESLint disable. Just like this, and then it should work. I mean, at least here in VS Code, we no longer get the problems that we had before. So let's reload here. Then let's again search for Interstellar. Okay, and now I will first select this one here, which has a rating that is not greater than 8. And well, here we already have some problem. It's because this actually must be after destructuring. So of course, at this point, the IMDb rating variable is not even defined yet. So let's just try that again. And again, let's select this one here. And so for now, we don't have any problems. So let's again check out the state here, or the list of hooks. And so indeed, we have our 6 hooks. So the same 3 states as before and the 3 effects. So that's because the rating in this case is just 1.7. And so then this use state here was not called. But now let's check out what happens with Interstellar, where the rating is greater than 8. So as we click, well, our application immediately stops working. So let's come here to the console, and then React immediately tells us that it has detected a change in the order of hooks called in this component. So it tells us here actually some helpful information. So in the previous render, there were 3 useState hooks, and then the number 4 was an effect. So this effect right here was hook number 4 before in the previous render. And that previous render actually happened after we clicked on the movie, but while the movie data had not been fetched yet. So at that point, the IMDb rating here was still undefined, and so then this useState hook was not called. But then as soon as the data arrived, the IMDb rating was indeed greater than 8. And so then React called useState here, and so then on the next render, the 4th hook was no longer the use effect, but this state right here. And so therefore, now clearly we can see that our linked list of hooks is different. And so React is not happy about that at all. So let's, of course, turn this off, and then it should go back to working. So this one is pretty obvious that we shouldn't use it. And also, as you saw, ESLint immediately warned us of that problem that we were creating. However, in certain situations, you might not have ESLint installed. And so in those cases, you really need to be very careful. Now, one more subtle thing that can happen is an early return. So if we say, if IMDb rating greater than 8, then let's immediately return some JSX here. Let's say greatest ever. And so if we do the same thing as before, Interstellar, then here the IMDb rating is less than 8, but as we click here, then we run into exactly the same problem. Now this time the error message doesn't contain the previous list of hooks, but still it tells us that this time fewer hooks were actually rendered. And so that's because right now we only have the movie, and so these 3 states, but then the effects, so the 3 effects that we had, they are now no longer created. So instead of the 6 hooks, we now only have 3 hooks. And so therefore, this again creates a big problem, because like this, we cannot guarantee that all the hooks are always called in the same order. So be very careful of that. And so now after this small experiment, you know what these error messages here mean. And so hopefully you enjoyed this small experiment. Let's just turn this off. And also let's remove this line right here, because of course we want ESLint to work so that it can warn us before we create a bug like this. Let's now look at the super important useState hook again and review some important details that we have already talked about as well. So, we have been using the useState hook since almost the beginning of the course because this is in fact the most important hook in React. So we have used it in many different ways and we know pretty much how it works at this point. However, I want to again review some important parts of it, and I want to draw your attention to one very important detail, which is the fact that these initial values that we pass into useState only really matter on the initial render. So let's see an example of that. And let's say that we actually wanted something like this here to work. So we wanted a piece of state called isTop, which is true if the IMDb rating is greater than 8. Now we cannot do this, as we already learned in the previous lecture, but we might think that this works. So basically doing this. So IMDb greater than 8. So let's see if that works actually. And let's then log this state to the console. Okay. Let's search for a movie as always. And then let's wait for it. And we see that this log here coming from line 266, which is this one here, is indeed false, even though the rating here is actually greater than 8. And if we take a look at our list of hooks, then we also see that this one is set to false. So why is that? Well, it is because of the reason that I just mentioned before, which is the fact that whatever we pass into useState is the initial state, and React will only look at this initial state on the initial render, so when the component first mounts. However, when the component first mounts here, the IMDb rating will still be undefined, and so this here is then false, and so it will stay false forever, because nowhere we update the state, and on the second render, so when we then finally get the movie data, this will not be executed again. And so therefore, again, it will stay false forever. Now, one way of fixing this would be to use a useEffect. So if we did useEffect, passing in a function, and then we wanted to run this effect each time that the IMDb rating updates. And so each time that does happen, then we want to call set isTop, and then we can do IMDb rating greater than 8. And so in this case, this should then work. And let's see, and indeed, now it is true. And if we take a look again here at our different hooks, we see that now indeed isTop is true. So our fourth hook here. And so that is simply because of this useEffect. Now, of course, in this situation, we shouldn't even use a piece of state in the first place. So if this here was the functionality that we really wanted, then what we should do is derived state. So we shouldn't create a real state with the useState hook, but instead we should just do const isTop and then simply IMDb rating greater than 8. So let's comment all of this here out, give it a save, and if we then log that again to the console, you see that this simple code works seamlessly. So let's wait for it here, cleaning our console. And so it is true. And so that's because this variable here is of course regenerated each time that the function here is executed. So after each render. And so this is the power and one of the great advantages of derived state, which is that it updates basically as the component gets re-rendered. And this is really as simple as it can get, right? So this is pretty important to understand, so that the initial state value here is only been looked at by React in the very beginning. So only on component mount. So never forget that. And now I want to come back to this function right here to give you yet another example or another proof that updating state really is asynchronous and that we need to use a callback function to update state in certain situations. So let's say that when we add a new movie to our watch list, right here, we wanted to display the average of the rating that we gave and the rating that is coming from IMDb. So we wanted that to be displayed right here instead of closing the movie immediately. So let's first of all here remove this part, and then let's create a new piece of state, because if we want to display something on the screen, well, then we need a new piece of state. So let's call this average rating and set average rating. And use state, and let's just set it to 0. And then we want to render that here, really somewhere. It doesn't really matter because we will remove this here in a minute anyway. So this is just to give you another demonstration of updating state asynchronously. So where is that function? Here it is. Okay, and so now here we should see the 0. And I used the value of 0 here and not the current IMDb rating because, again, this will just be undefined in the beginning. And so there's no need to place that there. All right, but then as we click on this button here, then this function here is executed. And so let's then actually set that state. So set average rating. And let's say that first we wanted to set it to the actual current IMDb rating, which is a string. So let's convert that to a number. So IMDb rating. And now watch what happens if we log this to the console, or maybe even if we alert this. So then it becomes really visible. So AVG rating. So let's see. And so the AVG rating should now be 8.6 because we set it to IMDb rating, which is 8.6. So watch what happens. Well, it is still 0. And so that's, again, because the state is set asynchronously here. Or in other words, we do not get access to the updated state right after doing that. So right after we call the state updating function. So only once React is done processing this event handler, it will then update all the state and re-render the UI. All right. But anyway, let's now do another one. So set AVG rating. And so let's now attempt to calculate the average. So taking IMDb rating, or actually we want the average rating. So average rating plus the user rating and then divided by 2. So let's see. Let's delete this here. And let's use 10 this time. And then we get a wrong average here. So our average is not correctly being calculated. So this 5 here is really just 10 divided by 2. So the reason for that is that here the average rating is still at 0. And so then 0 plus 10 divided by 2 is indeed the 5. But why is the average rating still at 0 here, even though we have updated it before? And by now you already know the answer. So it's asynchronous state setting, which means that at this point here, the average rating has not been set yet. So it's still at 0, which is the initial value right here. And so because of that, we say that the average rating state is stale at this point. So we have stale state right here. But luckily for us, we already know how to solve this, which is by passing in a callback function. And so that callback will get access to the current value. And so let's again call that average rating, but of course it could be called anything. So let's try one more time. Again 10, and beautiful. So now we get the correct average. Nice. So this time what happened was that the average was again set to the IMDb rating, so the 8.6, but then in the next line here, we already got access to that new value. And then here, the 8.6 plus the 10 gave us the correct average. And again, here this could be really called anything. And it would always work in the exact same way. So if we do that again, then yeah, we will still get 9.3. And so that's because this is simply the name of the argument of the callback function that React will pass into the function. So it will simply pass the current state value into the function, but we can then of course give it any name that we want. But let's put it back, and indeed, let's actually remove all of this that we just wrote. So this was just yet another experiment, but I hope that it was a helpful one. So here, actually no, I thought I saw some error there. So let's put it back, and so now the application should work just like before. All right, and now there's just one final thing to learn about the useStateHook, which is that besides using a callback like this to update state, we can also use a callback to initialize state. And so let's learn how to do that in the next lecture. In this lecture, we're finally going to build a brand new feature for our app, which is to persist the watch list in local storage. So right now, if we have some movies here in our watch list, and if we then reload the page, then you see that of course our movies are going to be gone. So they're not persisted, so they're not stored anywhere. And so that's why in this lecture, we will now use local storage to store this watched data information in the browser. So we're going to do this in two parts. First, each time that the watch list state is updated, we will update the local storage. So we will store that data into local storage. And then each time that the application loads, so when the app component first mounts, we will read that data from local storage and store it into the watched state. So let's do that, starting with the first part, which is to store the watched movies here into local storage each time that they are updated. And we can actually do that in two different ways, or in two different places. So the first option is to store that data into local storage each time that a new movie is actually added. So basically right here in this event handler function that is responsible for adding new movies to the watch list. So each time that happens, we can then store the new watched list into local storage. So that's the first option. And the second option is to simply do it in an effect. And so let's actually do both of them, starting here in this event handler function. Now, by the way, if you're not familiar with local storage, It's basically just a very simple key value pair storage that is available in the browser and where we can store some data for each domain. So basically, the data that we store in local storage now will only be available to exactly this URL right here, not, for example, in this other one. All right, and the way we use local storage is simply calling local storage, which is a function available in all browsers, and then we set item. Then we pass in the name of the key, so basically the name of the data that we want to store, and then second, the actual data. Now here we cannot simply use the watched array like this because it has just been updated here. And so as we already know, this updating happens in an asynchronous way. And so therefore, right here, this is still stale state. So it's basically still the old version before a new movie has been added. And so we need to basically do the same thing as here. So you need to build a new array based on the watched, so the current state, plus the new movie. And then finally, we need to convert all of this into a string, because in local storage, we can only store key value pairs, where the value is a string. And so let's use the built-in JSON.stringify. All right, and this should now actually work. Let's try some different movies now here. So let's try this one, which is actually one of my all-time favorite movies. So let's add that to the list, and maybe another one. All right, and so now we have our two movies in the list, but of course, if we reload the page now, they will not magically appear back in the UI, but we can still check if they have been stored into local storage. So in the DevTools again, we just come here to Application, and then here on the left side, you should have this local storage thing. And so, indeed, here we see that our array of watched movies has indeed been stored into local storage. Great. So that's working, but as I was saying, we can also do it right inside an effect. So instead of doing it here in the event handler function. And we will actually do it in an effect instead of here in this event handler function, because later in the section, we will want to make this storing data into local storage reusable. So let's just comment this out, and then let's come down here and create a new effect. So you see that I like to have always the states here in the beginning of the component, then the event handler functions, which update some of the state, and then in the end, the effects. So let's create a new effect with a function. And then, as we were just saying, we want this effect to run each time that the watched movies are updated. And so then here we can very easily, let's just grab this first part here, or actually all of it. So let's paste that here. And now we don't have to create any new array because this effect here will only run after the movies have already been updated. So after watched is already the new state. And so we can then simply use that here. All right, let's reload. And we see that our local storage has already been updated. And that's because this effect here ran when the component was first mounted. And so at this point, the watched state is by default still this empty array. And so then React set that here to the empty array. So let's just try, well, that's not correct. And for some reason here, the loading state is no longer working, but let's take a look at that later. So as we add new movies to the list now, we should see our local storage being updated. Nice. So that part is working, and so now we need to take care of the second part, which is to read this data back into the application as soon as the app component mounts. So the component that owns this watched state. Now, how can we do that? Well, we might think that we should use another effect in order to get the data from local storage on the initial render and then store that data in the watched state. However, there is actually a better way. And so let me show that to you. So let's deactivate this watched state here. And maybe let's move it down here and then duplicate it, because we still need this state, of course. So what we're going to do now is to, instead of just passing in a value, is to pass in a callback function. And so that's because the useStateHook also accepts a callback function instead of just a single value. And so we can then initialize the state with whatever value this callback function will return. And so let's try that out. So let's pass in a function here. So creating a brand new function. And so then let's create a new variable. Let's say stored value. And then we can just read from local storage with the getItem method. So getItem, and then the key that we used before to store the data in local storage. So that's this key right here. And so then we just need to return this value. And so again, React will then call this function here on the initial render and will use whatever value is returned from this function as the initial value of the state. And this function here actually needs to be a pure function, and it cannot receive any arguments. So passing arguments here is not going to work. So just a very simple pure function that returns something, and that something will be used by React as the initial state. And also, just like the values that we pass in, React will only consider this function here on the initial render. So this function is only executed once on the initial render and is simply ignored on subsequent re-renders. Now apparently there is some problem here, so let's check that out. So watched map is not a function, and I actually saw that coming because right now the local storage here is a string. So remember that we stored the data as a string by doing json.stringify. And then when we get the data back, we need to convert it back by doing json.parse. All right. And beautiful. So here, the movie that we added to our watch list before is now indeed back in our watch list after reloading the page. So we successfully stored the data in local storage and retrieved it as the application loads. So our callback function here is doing its job, and so this creates a much better experience for the user. So whenever the initial value of the useStateHook depends on some sort of computation, we should always pass in a function like this. So a function that React can execute on its initial render. So we should not call a function inside useState. So we should not do this. Okay, so this is very different. Here we are calling a function, not passing a function in. And so this we should not do, because even though React would ignore the value of this, it would still call this function on every render, which is not good. So never do this, and instead pass in a function that React can then call later. Okay, now let's again go back to our application tab here, because now we want to see what happens when we delete a movie from here. And you see that it actually automatically got removed here from the local storage as well. So why is that? Well, it's because thanks to our effect here, we have effectively synchronized the watched state with our local storage. So when the watched state changes, our local storage changes as well. And so this is a great advantage of having used the useEffectHook instead of setting local state right here in the event handler. Because if we had done it like this here, then we would also have to manually set the local storage here as we deleted a movie. So here we would then also have to do the exact same thing and use all this here as the new local storage. But so now, since we have basically synchronized the two of them, we no longer need to do that. All right, now let's just see what happens when we reload the page, and everything's working fine. Let's just do one more test. Add a few more movies to our list. Of course, this is a 10, not some other value. Okay, now I see we are getting some errors here, but maybe that was... yeah, that's because of the image not loading. And now when I reload, beautiful. Both our movies are still in the list. So we learned here yet another way of using the useState hook. So now we know that besides passing in a single value, we can also pass in a callback function. So this all can be a little bit confusing with all these different options that we have. And so in the next lecture, we will basically summarize everything that we know about the useState hook, since that is such an important hook in React development. Let's quickly summarize everything that we know about the useState hook in one single slide so that you can keep it as a handy reference. So, we use the useState hook to first create state and then the setter function that results from creating state to update state. Now, we can create a state variable in the simple way, which is what we do most of the time, but we can also create state based on a callback function. So whenever the initial state depends on some computation, for example, reading data from local storage, we can pass in a callback function like this instead of just a single value. And this process is sometimes called lazy evaluation. Now, this callback function is only called on the initial render of the component. So on subsequent re-renders, it will simply be ignored. Also, this callback needs to fulfill two requirements. First, it must be a pure function, and second, it should require no arguments in order to work. And that's actually it. That's how we create state variables using useState. And now, about updating state, we can again update state in a simple way just by passing a single value into the returned setter function as the next state. So in this example, the next state would be 1000. On the other hand, in many situations, we actually want to update state based on the current state. For example, increasing a counter by 1. So if that's the case, we can give the setter function a callback function like this. So a function that is pure and returns the next state based on the current state. And this is, in my opinion, the preferred way of updating state whenever it makes sense. Now, one important rule to keep in mind about updating state is that you should never mutate objects or arrays. Instead, you must create a new object or a new array which incorporates the changes that you want to make, and then pass that new object into the setter function. And we have done that multiple times already, but I just wanted to mention this here in the summary lecture as well. Okay, so in conclusion, both for creating and for updating state, we have both a simple way and a way that requires a callback function. So this can be a little bit confusing, which is why I decided to create this overview. So I hope that this makes everything crystal clear and that you have now mastered the useState hook once and for all. So with the topic of useState now behind us, let's turn our focus on something called refs. And so in this lecture, let's manually select a DOM element so that you see why we actually need refs in React. So as an experiment, let's try to automatically give this input element here focus each time that the search component mounts. So basically, each time the application mounts, we will automatically focus on this input field. Okay, and in order to do that, we actually need to select this element. And so let's try to do that with the tools that we already have. So we come here into our search component, which is where that input field is located. And so then we can basically use a use effect and then manually select this DOM element right here. So let's try that out. And then let's execute this effect as soon as this component mounts. So let's create some element by simply doing document.query selector, and then we can just use the class name that is already here on the element. So .search. Okay, just to see if this works, let's log this to the console. And you see that indeed there is our input field. And so now what we can do is to just say L, so just this element, and then call the focus method on that. And so this is just some straightforward, typical DOM manipulation. Okay, and so now if we load the application, and so you see as the application first loaded, this input field automatically got focused. So our code here is basically doing its job. However, as we learned at the very beginning, React is all about being declarative. And so manually selecting a DOM element like this is not really the React way of doing things. So it's not in line with the rest of our React code. So in React, we really don't want to manually add event listeners like this, and also having to add classes or IDs just for the purpose of selecting is not really nice. And again, not really the React way of doing things. So here we already had the class name, of course, but if we didn't, then we would have to now add that class name or ID here to then use it in the effect to select the element. Also, if for some reason we would need some dependency here, for example, if this code should rerun each time the query changes, then that would mean that we would select the element here over and over again, which is also not ideal. Okay, and so to solve all these problems and to make the action of selecting an element more declarative, such as everything else in React, we need the concept of refs. And so that's what we're going to learn about in the next video. It's time to introduce yet another React hook. And this time it's the use ref hook. And fortunately for us, this is one of the easiest hooks of all. And so let's now take a look. So we use the use ref hook to create something called a ref. But what actually is a ref? Well, ref stands for reference, and essentially it's like a box into which we can put any data that we want to be preserved between renders. Now, in technical terms, when we use ref, React will give us an object with a mutable current property. And we can then write any data into this current property and, of course, also read from it. So in this small example, the current property was first set to the initial value of 23, and we then changed it to 1000. So as you can see, this current property is actually mutable, so unlike everything else in React. But what's really special about refs is that they are persisted across renders. So their current property value stays the same between multiple renders. So just like state. And this gives us two big use cases for refs. First, as we just said, we can use refs to create variables that will stay the same between renders. And useful examples of this are preserving the previous state or storing the ID of a setTimeout function. Now, the second use case is actually far more important, which is to select and store DOM elements. So this is what we attempted to do in the last lecture, and which actually brought us to this lecture. So just like the ID of a setTimeout, a DOM element is also a piece of data that we want to store and preserve across renders. And so refs are perfect for this. Now, refs are usually for data that is not rendered in the visual output of the component. So usually refs only appear in event handlers or effects, but not in the JSX. Now, of course, we can use refs inside JSX too, but usually that's not the place for them. If you need data that participates in the visual output of the component, that's usually a good sign that you actually need state and not a ref. And speaking of state, just like with state, you are not allowed to write or to read the current property in render logic, as that would create an undesirable side effect. Instead, we usually perform these mutations inside a useEffect hook. Okay, now I've hinted a couple of times at all the similarities between refs and state, which is because these two are in fact quite similar. So let's now analyze what they have in common and what's different between them. So in a way, we can say that refs are like state, but with less powers. So what they have in common is that they are both persisted across renders. So the component remembers these values even after re-rendering. The big difference is that updating state will actually cause the component to re-render, while updating refs does not. So the big takeaway from this is that we use state when we want to store data that should re-render the component, and refs for data that should only be remembered by the component over time, but never re-render it. And this is basically also what we already learned back in the lecture on the fundamentals of state management. So remember that this diagram is taken from that lecture. Now, back then, we didn't know what a ref was, but now we do. Now, going back to the examples of preserving previous state and storing the ID of a setTimeout, these are pieces of data that we want React to remember between renders, but we don't want them to re-render the UI whenever we update them. And so that's why we use refs for this kind of data. So this is the main distinction between state and refs, but there are also some minor ones. So as we also just learned, state is immutable, but refs are not. Also, state is updated asynchronously, which means that we cannot use the new state immediately after updating it. With refs, on the other hand, updates are not asynchronous, and so we can actually read a new current property immediately after updating it. So basically just like any other regular JavaScript object. Okay, and that does it for this video. So see you back in VS Code. So let's now do the same thing that we did before, which was to automatically focus on the input element, but this time using a ref. And so let's start by getting rid of this way of doing things. And so again, let's now use a ref instead. So using a ref with a DOM element happens in 3 steps. First of all, we create the ref. And so for that, we use the useRef hook as we just learned before. So we just write useRef, and then we need to again make sure that it is now correctly imported from React. Okay, so let's go back. So we call the useRef hook, And then here we pass in the initial value that we want to be in that current property that we just talked about. Now, in this case, when we work with a DOM element, that is usually just null. All right, and so this will simply return a ref that we can give any name to. And so let's now store this into a variable called input element, because that's what we will want to store inside this ref. So we have our ref, and now as a second step, let's actually come to the element that we want to select. And so all we have to do is to use the ref prop, and then we just pass in the ref that we just created. So that's input L. And so now these two are basically connected in a declarative way. So there's no need to manually do some query selection like this here. So all we are doing is to tell React that the ref that will contain this input element here should be, well, this input element ref that we created. And so now, in order to use this ref, in the third step, we can use, again, the use effect hook. So a new function that simply runs on mount. So we need to use an effect in order to use a ref that contains a DOM element like this one, because the ref only gets added to this DOM element here after the DOM has already loaded. And so therefore we can only access it in an effect which also runs after the DOM has been loaded. So this is the perfect place for using a ref that contains a DOM element. And so now if we want to do the same thing as before, we just use our input element, and then remember that we need to read the current property, which is basically like that box where whatever we store in the ref will get stored. So input element dot current, and so this here is now really the DOM element itself. And so this is where we can then call the focus method on. And just to show you, we can also log this to the console, of course. So input element dot current. Give it a save, and let's manually reload here. And so you see that just like before, our input field got automatically focused. And also the DOM element itself was rendered here to the console. All right. And so again, this means that we successfully connected the ref that we created here with this DOM element. So simply by passing this ref into the ref prop. And so then in a use effect, after the DOM has been loaded, we can use this DOM element inside the ref.current property. All right, but now I actually want to do something a little bit more interesting. So to show you the new feature that we now want to implement, let's come to our demo here. And now when I'm anywhere in the application, I will hit the Enter key. So I just did that, and then automatically this input field got focused. And so that's a really nice feature so that we can very easily search for movies. So let's say that I had just searched for this movie, then I took a look at this one, and now at a certain point, again, I hit the return key, so the Enter key. So you see that selected the field, and it also removed all the search query text that was still in there. So let's implement that. And so for that, the first thing that we need to do is to listen for that key press event. And in fact, we already did something similar before. So in the movie detail, we already listened here to the key down event, right? Now in this case, we do actually need to manually select here this document and then add an event listener there. So there we cannot use a ref, but that's just the way that things work in React. So let's do that. So document.add event listener, and then on the key down event. And here let's actually again specify a callback function, which we will then create here. And we need to call it callback, and it gets access to the event object. And let's place that here. And so the reason why we placed this in a separate callback function was so that we could clean up after our event. So return, and let's use an arrow function here now, make it a bit shorter, add event listener, key down, and then the callback. Okay, but now of course this will work on any key press. So whenever any key is pressed, it will call this callback function, and then our element will get focused. But we only want that to happen when the enter key is pressed. So let's say e.code needs to be equal enter, and it really needs to be uppercase here. And so in that situation, then focus here on the input field. So let's see if that works. I'm going to hit the enter key now, and yeah, beautiful. But now let's say that I already had searched here for something. And so if I hit the return key now, then of course it will simply focus here, but it will not delete the text yet. But that's very easy to solve. We just say set query, which we already get access to here in this component. So we just set that to an empty string. And so that should now work as I hit the enter key again. And indeed, there it is. There's just one final problem, which is, let's say that I'm writing this and then I hit the enter key again. And so this will then delete the text that we have. So basically, we don't want all of this here to happen when the element is already focused. So when it's already active. But luckily for us, we can easily check which element is currently active thanks to the document.activeElement property. And so thanks to that, we can say if document.activeElement, which again is the element that is currently being focused, so if that is equal to our input element, so input L don't current, then just return. So in this case, basically just don't do anything. All right, so let's try that again. So that just works fine. But then if I write something and hit enter, well, then actually that still doesn't work. So let's try to reload our page. Maybe that will fix it. So let's try that again. So here it still works. And now, now it's actually fixed. And with this, we actually finish building this small feature. So it was just a minor feature, but it was very helpful to understand how we use refs to select DOM elements in the React way. Now there's just one small thing that I'm noticing here, which is that React is complaining about a missing dependency. And so, yeah, this is once again really helpful because it tells us immediately what we have to do. So here we have to also place the setQuery function. And so that's because the setQuery function is indeed a prop to this component. And so therefore, since we are using it here in the effect, we then need to declare it in the dependency array. Now this function is not really ever going to change, but React still needs this to be here in the dependency array. So after using a ref to select a DOM element in the previous lecture, let's now focus on the other use case of refs, which is to simply give us a variable that is persisted across renders without triggering a re-render. So let's just search for some movie here. For example, this amazing classic, Back to the Future. And so now let's say that behind the scenes of this application, we want to count how many times the user selects a different rating. So for example, let's say first I rate this 3, then 7, and then 9. So this means that it took me a long time to decide between the right rating of this movie. And so let's say that in our application, we somehow wanted to register that. Now, I said behind the scenes because we actually don't want this data to show up on the screen. So basically, we don't want like a counter anywhere here in the app, which tells us how many times the user has clicked here. So again, it should happen behind the scenes. And so this time, what we need is a variable that is persisted between renders, but that does not cause a re-render when it is updated. And so a ref is a perfect use case for this. So let's then come here to the movie details component and let's create ourselves a new ref. And I like to do that right here after the states. So let's call this one here count ref, and then again use ref, and then just like with use state, here we pass in the initial value of that variable. And so in the beginning, the count is of course at 0. All right. And so now the idea is that each time the user gives a new rating, so by clicking here on one of the stars, this count ref should get updated, so that then when the user actually adds the movie to the list, we can then add that here to the new watched movie object, so that we can then finally store that value somewhere, so that count that we're going to create here. But first, let's now take care of actually updating the ref. And the way we do that is again using a use effect, because remember that we are not allowed to mutate the ref in render logic. So instead, we need to use a use effect. Okay. And when do we want to update the ref? Well, each time that the user rates the movie again. And so that's each time that this piece of state here updates. Okay, and so now all we want to do is to take our count ref and then manually mutate the current property. So we can say that countref.current should be equal countref.current plus 1. Okay, and actually this updating here should only happen when there already is a rating, because the effect will also run on mount, and so then it will already add plus 1 here, even without the user having rated. So let's just say if there is a user rating, which in the beginning is not, because it will still be this empty string. Okay, so again, here we imperatively basically updated this variable. So with a ref, we don't have a setter function, but instead we simply mutate the current property which is in the ref. And so that's why we say that the ref is basically like a box that can hold any value. So we could, for example, also instead of just storing the count here, store all the different ratings that the user has given in an array. So that would also be perfectly possible. But anyway, let's then now come here to the function where the new movie is actually added to the watch list. And here, let's then create a new property, count rating decisions. And so this should then be equal to the count ref dot the current property. All right, and that's it. So this should now already be working. So let's test it out here. Let's just make sure to reload. All right. So let's count how many times we click here. So let's say first we think the movie is a 7, then maybe it's a 9, but then we think even better, and then we come to the conclusion that it's actually an 8. So we decided 3 times here, and so let's now add this to the list. Now in order to check out if this actually worked, let's come here to our app, so where we have our state, so that in there we can then see if the value was correctly set, because of course we are not rendering that new value anywhere here. So here it is, and indeed count rating decisions was set to 3, which are exactly the 3 times that we clicked on a different rating. Nice. So let's just recap what we did here and why this works. So we created this ref here where we want to store the amount of clicks that happen on a rating before the movie is added. But we don't want to render that information onto the user interface. Or in other words, we do not want to create a re-render. And so that's why a ref is perfect for this. So then each time the user rating was updated, the component was re-rendered. And so then after that re-render, this effect was executed, which means that after the rating had been updated, then our ref would be updated as well. So we would update the current property to simply adding 1. So we can actually make this a bit simpler. So just like this, or even could even do this. So this works just in the exact same way. And so then we just used the countRef.current property later down here whenever we create a new object to be added to our list. Now, of course, if we tried to do the same thing with a regular variable, then that wouldn't work. So let's try that also. Let's say count, so just count equals 0, and then, so let's just do the same thing here. So if user rating, then count plus plus. And then here we also need to add count, which for a ref we do not. And then let's just add that count here. And so then we will see that this doesn't work. So let's reload. Let's empty this entire thing. Okay, so clicking 1, 2, 3, 4 times now, add to the list, and then again we come here to the state. So once again, really helpful to have these dev tools. And then we see that we have 4 count rating decisions, but the count here is only at 1. And so this 1 is basically just the last click that happened. So the let variable, which is just a simple variable, is of course reset after every re-render. So it's always going back to 0. And so then when the last click happened, that 0 was here increased to 1, and then that count was added to the object. So in conclusion, this normal variable is not persisted across renders, and it doesn't trigger a re-render. On the other extreme, we have state, which does both of these things. So it triggers a re-render and it is persisted. And then in the middle, we have a ref, which is indeed persisted across renders, but it does not trigger a re-render when updated. And so that's why we normally don't use a ref in the JSX output. All right. So this was really just to drive home the message how refs are different from both states and also from normal variables. Okay. Now we still have some problem. Still have the count. Here it is. So forgot to delete this one. Okay. And later on, we will even see some other more real-world use cases of refs. For example, storing the ID of a timer to stop it. But for now, I hope that this use case of a ref also made sense to you. And we don't use refs all the time, but it's still good to know how they work and to keep them in the back of your mind. Welcome back. So the last part of this section is all about custom hooks. And so let's start by understanding what custom hooks are and when to create one. Now, custom hooks are all about reusability. And in React, we have basically 2 types of things that we can reuse: a piece of UI or a piece of logic. That's it. That's all the things that we can reuse. Now, if we want to reuse a piece of UI, we already know that we use a component. On the other hand, if you want to reuse logic, in React, you first need to ask the question, does the logic that I want to reuse have any hooks? If not, all you need is a regular function, which can live either inside or outside of your component. However, if the logic does contain any React hook, you cannot just extract the logic into a regular function. Instead, what you need to create is a custom hook. So basically, custom hooks allow us to reuse stateful logic among multiple components. And actually, not only stateful logic, but really any logic that contains one or more React hooks. So we can say that custom hooks allow us to reuse non-visual logic, which is a more generic term. Now, just like regular functions or components or effects, one hook should only have one purpose. So it should only do one specific, well-defined thing. So the idea is not to simply put all the hooks of a component into a custom hook and call it a day. No, the idea is to make custom hooks reusable and portable, so that you can even use them in completely different projects. And actually, now that we have had hooks for so many years in React, developers have started to share their custom hooks with the world. And so there are now lots of custom hook libraries that you can download from NPM and use in your projects. Now, since custom hooks are made out of regular React hooks, the rules of hooks that we learned about before still apply to them as well. Okay, but now let's look at an actual custom hook so that we can learn just a bit more about them. So, first, a custom hook is really just a JavaScript function, so it can receive and return any data that is relevant to this custom hook. In fact, it's very common to return an object or an array from a custom hook. And notice how this is different from components, which are also just regular JavaScript functions, but which can only receive props and always have to return some JSX. Now, the difference between regular functions and custom hooks is that custom hooks need to use one or more React hooks. So this custom hook here, for example, uses two useState and one useEffect hook to abstract a simple fetch functionality into this custom hook. And finally, in order for us and React to recognize this function as an actual hook, the function name needs to start with the word use. So just like all the built-in React hooks. So in this example, that's useFetch. And this is really not optional. So you need to give the function a name starting with use. Otherwise, it's going to be just a regular function in the eyes of React. Alright, and that's all the theory that you need to know about custom hooks. And so let's now go build ourselves some custom hooks for the rest of this section. And as our first custom hook, let's start with a hook called useMovies. So there are basically two strategies to decide if we want to create a new custom hook. So the first one is that we want to reuse some part of our non-visual logic, so just as we learned in the previous lecture. And the second factor might be that we simply want to extract a huge part of our component out into some custom hook. And so that's actually what we will do in this lecture. So we will take this useEffect here, which fetches our movie data, and we will extract it into a hook called useMovies. And so then we get rid of all of this code here in our component. And of course, if we wanted, we could then later reuse this hook in some other project. Okay, so in this lecture, I will show you how we can extract all the stateful logic that belongs together into a nice and well-packaged custom hook. So let's do that. And actually for that, I will create a brand new file here in our source, and I will then call it usemovies.js. Okay, and from here we will export a function which is going to be our custom hook called exactly useMovies. Okay, and notice that here I'm not doing an export default, but a named export. And so that's kind of a strategy that I like to use. So using default exports for components, like this one here, and using named exports for custom hooks. Now that's not really mandatory, but that's just the way I like to do it. So you could, of course, also do a default export here. Okay, and so let's start by extracting these use effect here. So this huge thing. And then we will notice that we will need a lot more stuff than just this here in this function. Okay, so give it a save, and immediately we see that we are missing all of these state variables. So in this case, these state setter functions. And so that's because fetching the movies requires a lot more than just this effect. So notice how we actually also need multiple state variables. So the movies is loading and error. All of them are necessary to make the functionality of fetching movies work. And so let's also extract them from here and paste them where they are necessary. Okay, and then we just have some problems with importing. So import use state and use effect from React. Okay, so that's looking already better, but we still have some missing information right here. So we're missing the key and we're missing the query. So to fix that, we can simply accept the query here, for example, as a parameter to our function. And so now remember that this really is a function. This is not a component, and so here we don't accept props, but really we accept arguments like this. So even though our custom hook is not yet going to work, let's already call it. So use movies. And so then again, VS Code will automatically import this for us. So now you have this line of code here, which again imports the custom hook that we just created. And notice how it's using here the curly braces, meaning that this is a named export and a named import. But anyway, now here we are calling our new custom hook, and so let's pass the query in. All right. Now we're not saving anything to a variable here just yet, because for now our custom hook is not returning anything. And so let's actually change that. So what exactly should we actually return from this custom hook? Well, basically we want to return everything that we need here in the app. So basically all the variables that somewhere in our JSX are necessary. And so that's basically exactly the three pieces of state that we just removed from here. So it's the movies, the error, and the is loading state. Because again, we will need these somewhere here in our JSX. So we have movies, we have is loading, and we have error. And so again, we of course now need access to these variables right here as well. And so that's basically what we will want this custom hook to return. And so let's return them from here. So I think that's the correct place. Yeah. So right after the use effect, we will return and we will place them all into one object. So it could be an array as well, but it's very common to just return an object, especially when we have so many different things like movies, is loading, and error. All right. Now here we actually have a problem now with this handle close movie. So let's comment this out for now. And now there's only one thing that we are missing here, which is this key. And so let's grab this, so copying it and then pasting that here as well. So we could also have passed this in as an argument into the function, but I think that the key itself really should be part of this file here, because it is tightly coupled also to the movie URL. And so if we passed in the key, then we should probably also pass in the URL, but that we don't want. So we want to make this as reusable as possible. Okay, and so now all we have to do is to then here basically get the data that is returned and destructure them here into their own variables again. So that's movies is loading and error. And so that's actually it. So again, here we are returning these three pieces of information, so these state variables that we are going to need outside of this custom hook. And so basically then this here returns an object which we then immediately destructure right here. And so then as far as the app component here is concerned, having this is exactly the same as having all the code that we had here in the component before. And so if we give this a save and try this now, then you see that it's working just like before. The only difference right now is that when we select a movie here and then we search for another one, let's say test, then this one here is not closed. And so that's because we are no longer calling handle close movie. So what should we do about it? Well, we can just leave it as it is right now. So in order to make this really reusable, or we could also accept a callback function that the user of this custom hook can pass in if they want, and then we can call that at the very beginning. And so this is a way of customizing this custom hook a little bit more. So we can think of these arguments here, again, a bit like the public API of this custom hook. So just like we can think of props as the custom API of a component. So a custom hook like this can also be created by someone and then consumed by someone else. And so that's the whole point of creating reusable pieces of stateful logic. Okay, and so, well, let's remove that from here. And just to make this a bit more clear, we can call this at the very beginning of our effect. So we can say callback, and then we only want to call it if it actually exists. And so we can basically do optional chaining on calling a function as well. So that's just like this, or actually the other way around. So like this. And so now this function will only be called if it actually exists. So without this optional chaining part here, we would first have to check if it does exist, and then we would call it. So if we now try this again, since we didn't pass in any callback yet, this will then work without problems. So you see, no problems there, but now we can actually pass in that callback, which is handle close movie. And we can use this function here before it is actually defined, because remember that in JavaScript, function declarations like this are hoisted. And so that's one of the big reasons why I don't like to do this, what many people do these days. So writing an arrow function like this. So if I did this, then I couldn't do it like this. I would first have to create a function. But like this, that's not necessary. And so one of the reasons why I always prefer function declarations. Okay, let's try this again. So let's open some movie. And beautiful. So now the currently open movie is immediately closed as the search query here changes. Great. So with this, we really cleaned up our app component here. So we only have like this small effect here left, but we will actually also take care of that in the future. And now let's just quickly recap what we did here. So basically, we took all the logic that belongs together to search for movies and simply placed it here into this custom hook. And notice that we used 4 hooks to achieve that result. So 1 use effect and 3 use states. And that's important because remember, a custom hook actually needs to use at least 1 React hook. Otherwise, it's just a regular function. Right? So we took all the logic that belongs together, packed it here into this one function, and then returned everything that is necessary for the app to keep working in exactly the same way as before. Now here we just need to probably also add the callback to the dependency array, but then you see we have this like infinite reload here of error. Now fixing this is too difficult for us at this point. So I actually didn't think of this because I hadn't even prepared this lecture here before. So let's actually go back, remove that from the dependency array. But since we should really not lie about our dependencies in the array, let's then remove the entire ability to do this. So I will just comment this out, take away the callback, and here as well. So then the custom hook will not work exactly the way as it did before, but that's not a big deal here. So we are just learning, so we just wanted to learn how we can extract this non-visual logic into a custom hook like we just did. And to practice this a little bit more, we will do a few more in the next few lectures. In this lecture, we're going to create a new custom hook called useLocalStorage_state, which basically will behave exactly like the useState hook, but where the state actually gets stored in local storage. And so with that hook, we will then be able to replace this code right here. So this state, which gets the initial value from useState, or from local storage, actually, plus this part right here, which is responsible for storing the state in local storage. Okay, so right in our source folder, let's create a new file for use local storage state. Okay, so export, and then again, use local storage state. Now, some people would probably just call this use local storage, but I want to make it really clear that the idea of this hook is to work in the exact same way as the use state hook. So of course here we're missing the function keyword. But now let's come back here, and in order for us to know how we should design our hook, let's first call it. So, as I mentioned, I want this hook to work basically the same way as the useState hook. And so it should also return an array of the state. So let's call it watched again. And of a setter function. So set watched. And then, well, use local storage state. And again, make sure that it is correctly imported. And then we want to pass in the initial state, which remember for the watched array was simply this empty array. Right? And so let's now comment out this. And actually before I will copy it and then comment it out. All right. So let's then come back here to our hook. And so first of all, we can specify the parameter. So the parameter here is basically the initial state. Okay, and now I will paste in what we just had there before, which is this state. So let's import use state here. Import use state from React. And now here I want to give these variables here some more generic names. Because remember that the idea of this hook here is to easily reuse it in other projects. So let's just call this value here and then set value. All right. Now, right now, we simply have a custom hook which sets some state and reads the state from local storage. But that's not super helpful yet, because of course we also need to update the state in local storage. So we also need to get this use effect right here. So let's cut that from here. And let's actually delete all of this as well. And then let's paste this here. And of course, we will have to rename then these things. So this is now no longer watched, but just our generic value, right? And then here we need to also import use effect. Now there's still one big problem here, which is that we have this key here hard-coded. So of course, again, this needs to be reusable and generic. And so therefore, we need to allow the user to pass in the name of the key. So this is not 100% similar to useState anymore, but well, this is really necessary. Otherwise, this cannot work. All right. Then here, we also need to pass in the key, because our effect here depends on that variable. Okay, and now to return, we simply return an array which has the value and set value. And so then it works exactly like the useState hook. So here we already destructured that result, so that array again into the state variable and into the state setter. Now here we just need to pass in that key. So that's watched. And as I save this, actually immediately our watched list is back, which means that this custom hook is fully working already. But let's just go back and do some fixes here. Because in the very beginning, if we had no local state at all yet, so let's simulate that here in the application tab. So let's remove this. And so now this doesn't really exist. And so then we should get some problem. So here in the console, now of course, we have these problems because now our watch list is basically null. And so then our app somewhere is trying to call the map method on that. And so we need to fix this. And we do this by actually using now the initial state, which up until this point, we actually have used nowhere. So we passed it in, but we haven't used it anywhere. So what we need to do now is to check if this stored value here actually exists, because right now it doesn't. So we can easily check that. So this will then be this null that we can see here. So yeah, there it is. And so we need to say here, basically, if there is a stored value, then return this, and otherwise, then return the initial state, which in this case is going to be that empty array. So let's get rid of this. Let's reload. And so then, as we come back here to the application, we will see that indeed now we have an empty array. So that's our initial state that was stored into local storage because of this use effect, right? So remember that whatever this function here returns will be the initial state value of this useState hook. And so then at the very beginning, value becomes this empty array. And then as this effect here is executed after the re-render, that value is already that empty array. And so that's what is then stored here into our local storage. Okay, so that's again it. So what we did again was to take all the code that belonged together and placed it into yet another hook. And in this case, we made it so that this hook looks as close as possible to the useState hook. So we also pass in some initial state, and then we get back a state variable and a state variable, and the updater function as always. But thanks to our special custom hook, now these work a bit different. So this piece of state here can be read from local storage as the component first mounts, while the setter function will not only update the state itself, but it will also update the local storage. And so we coded all this functionality right here in this reusable custom hook. Let's just test this one more time. So being sure that it works. Yeah, but here it appears. And as we reload, then there it is. So great. Just make sure that you understood what happened here. And if you want, it might even be a good exercise to put all the code back and then do it all again on your own. But anyway, if you don't feel like doing that, then let's just move on to the next lecture where we will create just one more custom hook. To finish this section, let's now create another custom hook called useKey, which will abstract the functionality of attaching and removing an event handler for a key press. So here in the movie details component, we have that functionality that if we open a movie and then hit the escape key on our keyboard, then it will close the movie. And so we implemented that using a useEffect hook. So this one right here. And so, since this is using a React hook, we can abstract this into its own custom hook. Because actually we do something very similar to focus here on this search bar. So again, when I'm here and I hit the Enter key, then that will automatically focus this. And so that is using basically some similar functionality. And so it's a good idea to abstract this functionality into a custom hook and then reuse that in both these places. So let's copy this code here. So just copy, and then let's create another file for another custom hook. So this one is called useKey.js. And by the way, I forgot to mention earlier that I actually also created a copy called app version 3 before we started extracting all the custom hooks. So basically that we can keep our code before those custom hooks were implemented. Okay, but anyway, let's now export the function called useKey. Okay, then let's just paste this here and import useEffect from React. Okay, and so now what do we actually need as inputs to this custom hook? Well, this one is actually the easiest one of all, because this one doesn't need to return anything, and all we need is to know what should happen. So basically we need a callback function here, and we also need the user of this custom hook to tell us on which key the effect here should actually be executed. So not the effect, but the callback that they will pass in. So we want the key. For example, in this case here, that would be the escape key. So here, instead of escape, we will have just the key, and then we want some callback for an action. So just like this. And then instead of calling, of course, onCloseMovie, we just call the action that the user passed in. Then here we also need the key. And so again, never lie to React about your dependencies, and always make sure to include every single variable that is used here into your effect. Okay, now here we just need one small fix, so to say, because the user might pass in this key like in different formats. So they might write escape like this, or maybe all in lowercase, or maybe by mistake they write like this. And so what we should do here is to just transform this key that they pass in to lowercase, and then also the code that we get from the event to lowercase as well, so that we can then correctly compare them. And that's a pretty normal thing to do when we compare strings. And so this should at this point already be working. So let's come back here and then let's use key. So again, make sure that the file was correctly imported. And if it didn't, then go ahead and do this line of code yourself now. And so here we now need to pass in the key. So that's, in this case, the escape key. So we want to replace this effect right here. And so that's again the escape key. And the action will be on close movie. So this function right here. With the difference that, of course, now we do not call the function, but instead we will allow React to call this function at a later point. So basically when this event happens and the key is the escape key. So this whole functionality is now inside that function. And so just to make sure, let's reload. Let's open up some movie, hit the escape key, and nice. So our custom hook is working. And so let's now immediately reuse it in this search component. So where is that? And of course, if I were writing this application for myself, I would have long divided this file into multiple components. So this is the last one. We will have one big file with everything. But anyway, let's now again use key here. And so this time the key that we are looking for is the enter key, like this. But now as for the callback function, this is actually a little bit more tricky, because watch at what we have here as the callback function. So we have all this, where this part here, of course, is already in the custom hook. So where it compares the pressed key with the key that we're interested in here. So basically this action here is corresponding to this part. So we could pass in a callback function like this, only with these two pieces, but then we would miss out on this part. So we also need to include that there. So this would then be like cutting it from here and pasting it here, which would not alter the functionality of this code at all. And so let's do the same thing here. So basically what we have here should now be just the callback function here. All right. And so then we can get rid of all this here once again. And also of this comment, since we also have this in that other file that I stored. And so let's see if this works again. So hitting the enter key, and yes, that works just as well. So here the callback function, so this action, as we called it in our hook, is a little bit different, so a bit longer than before, but all it does is to just describe what we want to happen when the enter key is pressed. Nice. So with this, we finished this part about custom hooks, and actually we finished this entire application. So we are done with this app. Let's just see why there are some problems here. Let's reload that. Okay, so that was from something else. But anyway, we finished now this application and this section as well. And so just like always, all there's left to do is one more coding challenge where you will now practice to build your own custom hook on your own. So don't skip that video, because it's pretty important that you start getting into the habit of writing these hooks on your own. In this challenge, let's practice creating a custom hook based on some code that is already working. So here we have a very simple application, which all it does is to get your position using geolocation as soon as you click on this button. So when you click here, your browser will then automatically ask for your permission, and then when you allow, it will give you your GPS position and the link which you can click and which will bring you to the OpenStreetMap application on your location. Okay. Also, the app then clicks how many times you have requested your position. And so if I click here again, then it changes to 2 and it loads again. Okay. And as I was saying in the beginning, I already have all of this code working here in your starter file. So the application, again, is already working just fine. And you can, of course, check out all the JSX code that I wrote here. But what matters is this other code. So all of this here outside of the JSX return. So my task for you now is to extract this logic into a custom hook called use geolocation, and then use that custom hook to make this component work again. So working in the exact same way as before. Now I want you to think about the fact that a custom hook should be as reusable as possible. And so, of course, I want you to write a use geolocation hook that you could then use in any other app that you will ever build. So if we think about this, then maybe those future apps where you might need this custom hook, they don't want to count how many times we have clicked on the button here, right? And so this state right here might not really be relevant to this custom hook. So this custom hook should really only contain the logic that is about getting the position from geolocation. And so that's what I want you to think about while you're doing this exercise. So again, basically make sure to not include this state here, which indicates how many times the button has been clicked. So that's a small additional challenge, but I'm sure you can do it. And again, the goal is to then have the application in the end look and work exactly as it is working right now. So take all the time that you need, and then I see you back here with my quick solution. So let's get to work. And so let's grab all the logic that is related to the geolocation. So that's all the state and also this event handler here, except for this counter here. And for now, also except this part here, although that is debatable, but let's just comment this out for now. So let's grab all this code right here, cut it, and then paste it here. But of course, now we will need to adjust a few things. And the first one is that, of course, now this counting logic here is no longer part of getPosition. So let's cut that from here and paste it into some function here. So let's say handle click, and then let's do that here. And so then here we will actually call that other function, because inside handle click is where we will then update the count clicks state and also actually get the position. So let's save for now, but of course we are now missing all of these variables here. And so just like we did previously, we now need to return all those variables from our hook. So that is actually pretty easy. So let's just return an object. So it is loading with position, with the error, and then also with the get position function. All right. And then we see here we have no longer any yellow underlinings. All we have now yellow is this function because we are not using it anywhere. So let's change that. So use geolocation, and then this will of course return an object with these names here. And so let's just copy that. That's a bit easier. So we will destructure all of that right here into these 4 variables. Now you could also have done this destructuring here right here inside use geolocation, and then instead of returning the position, you could have returned the latitude and the longitude separately. But here I just returned all of them at once, And we can now actually do nested destructuring. So we can also immediately destructure the position right here. So let and lng. And they are called this way because here we are constructing that position object with these exact property names. Okay, then we don't need this anymore. And then here, all we have to do is to also call getPosition. And with this, we should be good to go. So let's just reload here. And there we go. So the state updating works here and here as well. And of course, our link is also still working. Nice. So that's actually already it. So this was a fast one, but also a very important challenge, which hopefully made it even more clear how we create our own custom hooks. So basically, we take all the non-visual logic, so all the logic that contains some React hooks, and which is relevant to a certain thing. And so in this case, that thing is to use geolocation. So then we took these 3 state variables and also this event handler function, and then returned all of that from here and used it here. And so then we encapsulated all of those states and all the logic inside this custom hook. Then, of course, this state we left outside, which then forced us to do a couple of changes here in the event handler for the button, but all that is pretty simple. And so I hope that you had some fun with this and that you're now ready to move to the section that is coming up next. So see you there.